Hey, Sydney, welcome. And welcome back. I think I recognize your name, so I think maybe this is not the first research team meeting you've been to. Hi, Juliet. Gretchen's here, welcome. Josh. Tammy from Philly is here. Sydney's been to all four now, wonderful. All right, great, welcome. So those of you that are just joining us on the Zoom call, again, feel free to introduce yourself in the chat. Tell us who you are and where you're from. I think we're just about ready to get started. So hello, everyone, and welcome to your Environmental Engineer Research Team meeting. My name is Rachel, and I'm an educator here at the Franklin Institute. So I know some of you guys are watching us on our live stream today. So if you're watching us on the live stream, welcome. We hope that you all will be having conversations with each other in your groups, in your own chat as well. We're glad you're here. And for those of us that are joining on Zoom, we are going to be using the chat today, as a lot of you are already, as the way that we talk to each other and share our ideas about science. So if you have some ideas to share or results from our experiments, go ahead and type those in the chat. But remember that we're going to keep the chat for science. This is a place for us to discuss the results of our research. So put all of your ideas about science in the chat. If you have things to say that are not about science or not about the research that we did, save those for another time. All right, welcome to all of you again who are introducing yourselves in the chat. Hi, Lucas. Hi, Susan. Hi, Parvi. Hi, Alicia. Welcome to all of you. All right, so we are part of one environmental engineer research team that has been working on solving these problems, but we are not the only ones doing this research. I'm going to show you, oops, here we go, show you a map. So all of those red dots that you can see on the map of the United States are all places where people like you are doing these same engineering activities this summer. So there are folks in Maine and Oregon and North Dakota and Florida and Ohio, all over the country, doing these same environmental engineer activities. So we've got lots of research teams working on these problems. All right, welcome again to all of you. Hi, Autumn. Hi, Adonis. Hi, Zoe. Hi, Trayton. Glad you're all here. All right, so as part of the environmental engineer research team, we were being environmental engineers. So what do you remember about what kinds of problems environmental engineers solve? So engineering is all about solving problems, but what do environmental engineers do? What kind of problems do they solve? If you have ideas about that, go ahead and put them in the chat. Things involving nature. Definitely, so the environment involves nature. The environment, so things with water flow, that was definitely part of what our research was about. Protecting the environment, so solving problems to take care of things like people, water, soil, nature, stuff about nature, right? So the environment is all about nature, about animals and plants, soil and water and land. It can be about cleaning the streets. So part of our environment is the environment we live in. So that can be our cities and our streets too. Wonderful. You might work on recycling or waste disposal. Things like that. So lots of us have ideas of where it's about things involving the environment. So taking care of the air, the soil, the water, and the land. Exactly. So as we think about that, before we get started, I have a question for you all. And I'm going to put up a poll that you can answer this question. So my question for you is, did doing this activity, this research project, make you more interested in being a scientist one day for your job? And you can choose from, it made you a lot more interested, a little bit more interested, or not at all interested. So hopefully you've seen that poll pop up on your screen and you can answer it. If for some reason you don't see the poll and you just like to share your idea, your answer in the chat, feel free to do that too. So did this environmental engineer activity make you more interested in being a scientist one day? Joshua says, I'm already a scientist. Definitely. So we can be a scientist even if you don't do it for your job, right? Do you think you might be more interested in doing it one day for your job? Some of you say a little bit. I see a yes. Parvati says a lot. Hannah says yes, great. Oh, okay, sorry, Jonah. Yeah, I know we can't actually rename ourselves, so I will try to remember who you are, but if I call you with the wrong name, I apologize. Christina's interested in being an astrophysicist. All right, so let's take a look at the results. So you can see that red bar there, most of us said it made us at least a little bit more interested in being a scientist one day. And a bunch of you also thought it made you a lot more interested. And some of you said maybe not at all. And that's okay too. All right, so as somebody has already mentioned, part of our jobs as our environmental engineer research team was to work with a city. So our job was designing rainwater systems, right? So you might remember that we were working with a city who wanted to build a playground on a hill, and they were trying to figure out what would happen to the rainwater. They didn't want the playground to flood, and they wanted us to help them to figure out where on the hill we should put the playground so that it didn't flood, and then design a system to keep the rainwater away from the playground. And so you might also remember that we did what a lot of scientists and engineers do when we have a problem that's really big or a project that we're really big that we're working on, like a big giant hillside. We use a model. We use a smaller version to help us solve the problem before we do it with the real thing. So you might have a model that looked something like that picture on the right there. We used a paint tray as our model for the hillside. And we tried to figure out where on the hillside to put the playground and how we could keep the rainwater away from the playground. So we'd like to hear from all of you what you found out from your research. And if you might remember, the first thing that we had to do was to do some observing, right? To pour some water on our model and notice where the water went to help us figure out where we might want to put the playground. So I'd love to hear from you. When you first tested your model by pouring water on it, what did you notice about where the water went? Nice. So Megan says you did a storm drain at your school this summer. Interesting. Some of you made your own prototype using cardboard. All right, so we noticed the water went to the bottom of the hill. The water collected at the bottom. And then Prayal says the water had taken multiple paths to end up at the bottom. So it went to the bottom, but it didn't all go to the same place. It went in a zigzag pattern, some of you saw. It went down the sides. Notice that when you're using the one provided in the kit, it usually randomized in a zigzag. Interesting. Yeah, so I know the picture that I have of my model is a little bit different, but your model might have had little dots on it that maybe that made the water go in all different directions. The water went to the side. It went straighter with a heavier flow. That's an interesting observation, Jonathan. So when it was just a little water, it went more zigzaggy, but when there was a lot of water, it went straighter. Great. The water had taken different paths, but it all landed in the same spot. Right. All right, so some of you had the same results. It was true for you too. Great. Yeah, and for those of you that didn't have a chance to make your model yet, that's okay. You'll get some ideas from what we're talking about, and you can always make predictions, right? Scientists and engineers make predictions about what they think is going to happen, even if they haven't tried it yet. All right, so it sounds like we have some great ideas about where the water went. So what did that tell you about where would be the best place for the playground? Where did you decide on the hill that the playground should be? The top, at the bottom, in the middle? What did you decide? Crystal says on the top. All right, we have a lot of votes for top, looks like. Some folks figured out the bottom maybe was the best place. Erica says the playground near the top of the hill, but with about a quarter of the hill above it. So not all the way to the top, but just sort of towards the top. All right, so it looks like we have a lot of different ideas. Lots of people thought the top, lots of people thought the bottom, and some people chose the middle. Yeah, so some folks thought if it was at the bottom, then maybe the water would collect in the playground. But Sydney says, but at the bottom, you could create your own drainage. So that's where the water goes. But if you can make it drain somewhere else, then the bottom works. Right. And the nice thing about the bottom is that it's flat, right? We also have to think about what the playground is going to look like. So my picture that I showed on the screen showed a playground on the hill, but sometimes you want a flat part for your playground so that you can put the playground equipment on something that's flat. But then you have to solve the problem of what do you do where the water goes? Lots of bottoms, lots of middles. At the bottom of the hill, says Kevin, but before where the water collected. All right, so not all the way to the bottom with enough space for the water to collect. All right, it sounds like we have lots of different ideas about where the playground could go, which is great. And I'm glad we have some ideas because I have been working on a model myself, and I'm hoping that you all as engineers can help me solve some of the problems that I'm having with my model. So I'm going to switch my video camera, which means I'm going to disappear for just a second here. And then we'll show you my model. All right. So that's what my model looks like. So again, it might look a little bit different from what your model looks like, but see if I show it here. So here is the top of the hill. It's sort of slanted down to the bottom down here. And I've got it sitting up on a book so that it makes that sort of nice slanty hillside. So what I decided to do was to put mine similar to what someone else said. I decided sort of towards the top, but not all the way to the top. So you can see I outlined where I think my playground is going to go with this black outline here. And I started trying to build a system to keep the water away from the playground. So let me just show you what I have so far. So I started with a wooden popsicle stick and some Play-Doh to kind of make a wall to prevent the water from getting in the playground. But I noticed when I had just that there was some water leaking underneath the bottom of the popsicle stick. So I also added on this other side over here, it's a little bit harder to see, but I added some aluminum foil right there to kind of fill up the crack, and then some tape. So that's what I have so far. Kevin says they used a wall too and noticed the same thing. Right, so it's kind of good at stopping the water, but it tends to leak under. So that's a problem that we have to solve. Good, Chandana says you used foil and made a U or V shape. Wonderful, so I'll hear more about your ideas in just a little bit, but I'm wondering if you can help me with the problem that I'm having. So when I test this model that I have so far, I'm gonna pour some water on it to show you. And I put some blue food coloring in my water to make it a little bit easier to see. So let's just pour some water on here. So here's our rainstorm happening. What do you notice about what happens to the water in my model? All the water goes left, right? So all the water is kind of hanging here, says Anthony. Anything else you notice? It's getting stuck on the wall, right? So let's think about it, and it's also sort of leaking through there a little bit. So you can see some of it is kind of running down through the cracks there. Right. So let's think about what that would look like in a real playground, right? So if we had a real playground, and this was the lawn or the grass, what do you think this would look like up here where all the water is collecting? It would be some, yeah, so some of it is still flooding. So maybe I haven't quite solved my problem of leaking out underneath the middle. Not good. It would be a swamp, right? It would be muddy, it would be a flood, right? So if the water all sits up here, we're gonna have kind of a muddy mud puddle up there. So that's maybe not what we want. Even if it's not in our playground, probably people are gonna have to walk around there. You don't really wanna have a mud puddle there either. So what do you think I could do to help solve that problem? What could I change or add to my wall here that might help it not do that? Go ahead and put your ideas in the chat. Donna says mud, yep. Could use a sponge, add cotton balls. Interesting, so if I could add something that would help to soak up the water. We could add a drain, great. You know, the one problem with my model is that it's made of metal, which is gonna make it a little bit hard to put a hole in it, but that's definitely something I could think about. Use cotton balls, change the wall to a V shape. Some of you said make an angled wall, adding cotton balls for trees. Interesting, yeah. So if we think about our model and what that might look like in real life, probably we're not going to put cotton balls on a park for real life, but there are things in real life that do soak up water like a cotton ball, like trees and plants. So we could imagine that our cotton balls are trees and plants. Oh, lots of ideas here. More layers to the wall. So maybe make it longer or make it thicker. I had a couple people say making it go to the side by making it a curve or a slant. And I see lots of people saying adding plants or cotton balls to soak up the water. Interesting. All right, so let's see if we can try some of those ideas. So I think I heard lots of people saying maybe slant it and then maybe adding some cotton balls. So let's do one of those things at a time. Let me start by slanting mine a little bit and see what happens. So if I make it sort of more like a V shape, I think some of you were saying, or a curve. And I might need a little bit more Play-Doh to help it stick. Yeah, so it sounds like a lot of you tried similar things. It says the cotton balls will soak it up, but you had to put a lot of them. So that's something to think about. All right. Oops. All right. So we've tried this first change that you suggested by making it kind of a V shape. And I might need a little more tape also. It's not sticking quite as well. Lauren says they built theirs on cotton balls and made the playground on cotton balls. Oh, interesting. So maybe if the surface of the playground was something that could soak up the water, then it wouldn't matter if the water got on the playground because it would just be soaked right up. I wonder what that would look like in real life. What would the floor of the playground look like? Would it be made of real cotton balls or would it be something else that soaked up the water? Cotton balls would hit a saturation point, right? So maybe at a certain, they could hold a certain amount of water, but they might not be able to hold all the water if we had a really heavy rainstorm. That's a good observation too. All right, so I've slanted it a little bit here and put some tape to hopefully hold it in place. All right, let's test that again and see what happens. Well, he says dirt could soak up the water. Now that's a good observation. So dirt can definitely absorb water as well. All right, let's try this one. So I'm going to pour it again. And let's see what happens. All right, so what do we notice? Did that help to improve the problem? Yeah, so it looks like now that I made it a little bit more slanted, it's not collecting up here in the top like it was before. Brandon says the cotton ball skin in the playground could be a ball pit in real life. Whoa, that would be so cool. If you could have a ball pit to soak up the water somehow and you could still play in it, that would be very cool. All right, so it helped a little bit. Yeah, so it definitely didn't back up and make a big puddle here like it did before. But I think I noticed that it was still, once it came around the corner here, it was still kind of running down into the corner of the playground and getting the playground wet there. Yeah, a little bit still collected, but maybe some clay in the front would help to smooth it out. Interesting. So in the front, you think like over here or in the front in the corner? Yeah, it was definitely better, say Clara and Max. Maybe we can make it even better, right? Engineers, we always think about how we can make it even better than it already is. So we have some other ideas that could make it even better. Like a bead of clay across the front of the wall, like across here. Got it. Let's try that. I might need to dry it off just a little bit because it's kind of wet. So maybe if we put a layer of clay right along the corner, that might help. Side walls, so the water can't creep into the sides. Smooth the bead with water. Oh, I see. Okay. So I'm going to just add a little bit from that suggestion. And then someone else was suggesting maybe putting something along the side here. So let's think about what we want to put along the side. Do we want to make another wall or do we want to use some cotton balls? Anne says they made 2 sets of walls to block the rainwater. The first wall blocked the water coming down the hill and the second wall protected from flooding the playground at the bottom. There was Play-Doh on the second wall and also some cotton on the sides. Cotton balls around the edges of the playground. You could use clay. So many ideas, it's hard to know which one to choose. Thank you all for all of your ideas. All right, well, I heard a bunch of people talking about making a wall and maybe adding some cotton balls. So let's add another wall. We'll just add one going along the side here. It's seeming like maybe I'm going to have that same problem of leaking in the corner. So I'm going to take, I forgot whose suggestion that was, but maybe I'll use clay along there to try to plug that hole too. And then some cotton balls. So it sounds like a lot of you maybe had some of these same problems that I was having, and it sounds like you've come up with lots of good solutions for how to solve them. All right. So I think I've got that hole sealed up, and then we were going to add some cotton balls as well, just to make extra sure. Wow. Thank you all for sharing all of your ideas. They're coming by so fast, I can't even read all of them, but I hope that all the rest of you are getting to see the other ideas that your engineers have come up with. So I could make it higher than before so the water can't get in. Good suggestion. All right, so we've added a second wall. We've added some cotton balls to help soak up the water. Let's test it again and see what happens. Oops. All right, any observations this time? What did you notice? Do you think this was better? Much better, says Kevin. Yeah, definitely. So I noticed something pretty interesting. When I was first pouring, I could see a little bit of water coming in here. So maybe my seal was not as tight as I thought it was. But then the water went away again. It got soaked up by the cotton balls. So it started to leak and then got soaked up by the cotton balls. So in the end, it worked pretty well. Yeah, no water came in. Right, so there was just that teensy crack. So probably I still need to do some work about that teensy crack in the bottom if I could make that a little bit tighter, but otherwise it seems to be working pretty well. Because so Juliet noticed, so this cotton ball got really blue, right? There's lots of water being absorbed in that cotton ball right up there. And that's a good observation, Elise. So Elise is noticing that as I'm pouring more and more water, the level of the water here is getting higher and higher and higher, right? So maybe one rainstorm might be okay, but if we had 3 or 4 rainstorms in a row, we might need to start thinking about, what if the water comes all the way up to here? Is it going to flood the playground here? So maybe we want to put some cotton balls there just in case. Lucas says putting clay all over the sticks and a layer of cotton balls. Yeah, Anthony, I did. I put blue food coloring in the water so that you could see it a little bit better. All right. Yep, that would be a really big mud puddle, wouldn't it, Crystal? Think about that. That would be a lot of mud. So we probably have to think about, you're absolutely right. Some of you that were talking about a drain system. Another thing we probably need to do is put a drain in there so that all this water doesn't keep building up. All right. Well, those are some great suggestions, everybody. Thank you for your help, because I think probably I still have some work to do, but we have a lot of good ideas for how I can keep making this system even better. So I'm going to go ahead and switch my video back. And then I should reappear again in just a minute. All right. Well, thank you all for help with my project. Now I'd like to hear a little bit more about your projects. So what are some things, as you think about the problems that you are trying to solve? Here's our rainwater system again. Before we even find out what you did, we know that one of the things that engineers do is try again and again and again. You saw me trying a lot of different times. You can even see some pictures here on my screen of some of the different things that I tried and that we tried again just now. So before I even hear what you did, I want to hear from you. How many different ideas do you think you tried before you found what you think was your best one? Or how many different times did you try? Go ahead and tell me in the chat. Was it 1? Was it 5? Was it 15? 2, 2, 4, 1, 4, 5, 2 to 3 different times. Kelly says 6 or 7. Salim says 2. Kathleen says 100. Lots and lots of different times. 10. 100, 100, a lot. Yeah. And that's great, right? That's part of what we do as engineers is we try one thing, and then if it doesn't work, we try something else. And then even if that works, we see if we can make it even better and try something else. So it sounds like a lot of you were doing just exactly that. Great. So we definitely tried lots of different things. What are some things you tried that didn't work? Before we even get to the things that you ended up with, what are some things you try that didn't? Suganya says maybe 20, you're not even done. You're still working on it. Great. Lauren tried a fence. So that was maybe something that you thought was an idea. Putting it at the bottom didn't work. Right, so we saw on my model that that problem with the bottom is how much water builds up there. Using only sticks, right? That's a problem that a lot of us had, that I had too. Not enough cotton balls. So cotton balls help, but they only hold so much water. Chandana says putting a straight line of foil was something that you tried that didn't work. And Autumn's not done yet. Yeah, that's great. It's okay if you're not done yet. You can always keep trying to and working on it to make it better. So popsicle sticks by themselves. A lot of you tried that and maybe that didn't work. Not enough clay to make it stick, says Prabhati. Cotton balls and clay only on one side of the fence. Oh, interesting. So maybe that's something I could have thought of too. I only had cotton balls on one side, but maybe I should have thought about cotton balls on both sides. Anirudh says putting the playground in the wrong place, right? So thinking about the best place for the playground is something that you might try again and again. Not enough tape. Only the fence at the top and not on the sides. Yeah, that sounds a lot like what I did, right? First, I tried just the fence at the top and that didn't work very well. Didn't balance. All right, so we all tried lots of things that didn't work. And then we found some other things that worked hopefully a little bit better. So now I'd love to hear from you. What are some things you tried that worked well? What did you end up with that was your best so far, even if you're not done yet? So Ganya says by making the wall stronger by adding more tape and craft sticks. That's something to think about too, right? The wall has to stand up, not just for a minute, but it has to keep standing up. So making it stronger, using clay to hold the sticks, using those cotton balls as shrubs or plants, right? And having it on both sides of the fence. Pipes and a drain. I would love to hear what you did to make a drain. That was a little bit harder to do on mine because it was made of metal, but if you made a drain, what did it look like? Yeah, so Lauren's, oh, interesting. So Lauren put the playground up higher above the cotton balls to represent the dirt and gravel to make it a little bit higher so the water would go around it. Lucas found out that clay works better than tape because the tape won't hold to a lot of water, right? So if we were thinking about building these walls in real life, we would have to think about materials that don't, that can hold water, right? Because like we found out with our tape, we probably wouldn't use tape in a real bridge, but whatever we use is going to have to still stick and stand up even when it gets wet. Right, so the clay holds the water. Christina, you used a bowl. Is that what you used for the drain underneath? Wonderful. That's some good creative thinking to think about things you could use other materials besides what you had. Oh, Crystal says they had a big brain idea to reuse the rainwater and filter it and put pipes underneath to make a water fountain. Wow, that's a great idea. So you're not even just thinking about the playground, but what are we going to do with all of that water after we drain it out? So what if you filtered it and recycled it and made it into a fountain so you could have a fountain on the playground as well? That's a great idea. Using popsicle sticks to make a wall and then modeling clay to hold them in place. And gluing. Parvati says they glued the cotton balls to the wall so that it could absorb most of the water, so making sure they were nice and stuck there. Great ideas. All right. Yeah, so it sounds like although some of us had some of the same ideas, we also had a lot of different ideas for different ways to solve the problem. And that's one of the great things about engineering and engineers is that we need lots of different people with different ideas and different ways of thinking to come up with different ways to solve the problem. So thanks to you all, I think we do have a lot of really good ideas that we can tell the city about different ways that they could build their playground, different places they could put it, and different ways that they can keep the water away from the playground. So we've come up with lots of different and good ideas. So I wanted to tell you a little bit about someone who does the same kind of work, who is an environmental engineer. There's some pictures of her. Her name is Draisha, or Jay Brannan. She lives in Oregon, and she's an environmental engineer. But what's interesting is that she didn't always want to be an engineer. When she was growing up, she was actually really interested in art. She liked to paint, and she liked to work with fabric and make jewelry. Christina, she's from Portland, Oregon. It's a good question. And one of the other things she also really liked doing was helping people. So you can see that picture in the middle there. She was helping to collect toys to give as gifts for kids who didn't have them or who needed them. So it wasn't until she got to high school that she learned about engineering but she figured out that environmental engineering was a way that she could combine all the different things that she likes. So engineers have to be creative to think of ideas. And so she could use her creativity that she liked to do from art. And she could also use engineering to help people, right? Because the environmental engineers think about protecting the people and the environment. And so she actually got a job working for her city, the city of Portland, as an environmental engineer so that she could solve problems and be creative and also help the people and the city that she grew up in and that she loves. Yeah, Parvati, you like art too, right? So you might not think originally art is about engineering, but if you like art and you like to think creatively, those are things that you can do as an engineer as well. And she actually worked on a project that was pretty similar to what we did. So she was working on a rainwater system in a park in Portland, trying to make sure that the rain stayed away from the trails and the paths that people walk on, but also making sure that the rain didn't damage the plants and the animals that make the park a beautiful place to be. So if you want to find out more about Jay and the work that she does and how she got to be an engineer, there is a short video that you can watch. We'll put that link in the chat. So if you want to watch that later and find out a little bit more about her and how she got to be an engineer, you can do that as well. But I think it's a neat story because it reminds us that whatever you're interested in, there's probably problems that engineers solve that are related to that, right? So if you're interested in art or you're interested in music or you're interested in sports, there are probably engineering problems that have to do with all of those things. So now it's time to think about you and what you like and how you were like a scientist. So I have a couple more questions for you. If you think about doing this work with our environmental engineer research team, I'd like to ask you to think about how did you think or act like a scientist when you were doing this environmental engineer activity? So we're putting up another poll there. And for this poll, you can choose as many of those answers as you want. You don't have to just choose one. So how did you think or act like a scientist when you were doing this activity? Did you observe something? Did you test something? Did you try again? Did you ask a question? Did you have an idea? Did you learn something new? Did you work together? Did you have fun? And for those of you that maybe had the lab notebooks, some of you have these and some of you might not have, you might recognize some of those answers as the stickers that were in the lab notebook. So if you used the stickers in the lab notebook, that might help you to remember which of these things you think you did. And again, if you don't see the poll, you can just put your answers in the chat. So how did you think or act like a scientist when you were doing this environmental engineer activity? Anne says they think they did all of them. Great. Lauren says the same. Now we've got a couple of votes for same. That's great if you think you did all those things. Oh, Brandon, so you've been here for one of our other team meetings. Great, welcome back. So I wonder how you think you were different in this one than you were in the electrical engineering one. Did you do all the same things that were like a scientist, or were some of them different? All right, so let's show the results. Wow, so you can see all those bars that are almost to the end. So lots of us, it looks like, did lots of these things. Lots of us observed and tested and tried again. Most of us had an idea. A lot of us also learned something new and worked together and had fun. Yeah, so it looks like a lot of us maybe did all of those things. That's great. So as we're thinking about this, those are all things that we did that are like what scientists and engineers do. I have one more question for you. Did this activity show you that you can do science? And how much? Did it show you a lot that you can do science? Did it show you a little bit that you can do science? Or did it not show you at all that you can do science? So one last poll here. And again, if you can't see the poll and you want to just tell us in the chat, or even if you did answer the poll and you still want to tell us in the chat, that's okay too. Well, good, Noah and Josh, I'm glad you're having fun. Yeah, and some others of you were here for all four of the scientists, the engineers. That's great. Yash did the electrical engineer. Wonderful. Lots of you saying a lot. Great. Yeah, and as Lahiri's mentioning in the chat, if you couldn't make it to the other research meetings, you can find them on our YouTube if you want to watch them later. Great, fuck, I'm glad you're having fun. All right, so it looks like most of us said that this showed us a lot that we can do science. Wonderful. Great. Thanks everybody for letting us know what you did and what this was like. So we're just about done with our research team meeting for today. Thank you all for all of the work that you did as environmental engineers. I know many of you have said you have already seen some of our other engineering activities, but just in case you haven't, you can go to our website at scienceinthesummer.fi.edu. And there are, as some of you have said, 3 other environmental engineers and engineering activities that you can try out. So there's electrical engineers, structural engineers, and biomedical engineers. So if you haven't tried out the rest of those, definitely check those out. And remember that there's engineers solving problems in all kinds of different areas. So whatever you're interested in, music or art or sports, probably engineers solving problems in those things too. So if you want to find out more about what sports engineers do or what engineers might do related to art, you could definitely do some research on the internet or in your library and find out more about those kinds of engineers as well. All right, well, thank you all for coming today. And I also want to say thank you to GSK for making this program possible for us to be together and do this engineering research. So I will stay around here for just a few minutes. For those of you that are on Zoom, if you have questions or other comments that you want to share, feel free to put those in the chat. And for the rest of you that can't stay, thank you for being here and have a great day. All right. Thanks, everyone. Again, anyone